Lesson is on problem solving. So this is our last lesson for our algebra unit. You all have seen my tech skills, so I'm going to try and do this one a little bit differently. But as always, please bear with my skills and we'll get through this lesson. So when we're modeling word problems with algebra, we always start by introducing our variables, by identifying what they represent. So these are the steps that I want to see when you guys are problem solving. So when you're doing your work, each of these steps needs to be followed. I need to see clearly each one of these steps. So the first step is the let statements. So this is where we identify our variables. So you have seen these before. They're let x represent, or let m represent, or let x be. Whatever it is, we need to define our variables or identify them. Next, we set up an equation to model the situation. So based on our variables, we model with an equation. Then we solve. So using our algebra skills that we've learned throughout the unit to solve the problem. And then finally, we just answer the question using a therefore statement. So we are going to walk through these examples using these 4 steps. So the first question says 2 integers sum to 23. One number is 3 more than the other number. Find both numbers. So here, when we look at it, we see 2 integers. So that's either a positive or negative number. And they sum to 23. So they add up to 23. Then it tells us that one number is 3 times or 3 more, just 3 more. So adding 3 than the other number. Find both numbers. So the first thing we want to do is write our let statements. So we are going to let x represent one number. So we know we have 2 numbers. So we're going to let x represent one of those numbers because nothing is really happening to that number. But we know that there's something happening with the second number. So one number is 3 more than the other number. So then we're going to have let x plus 3 rep the second number. So here we have defined our variables. Let x represent the first number and let x plus 3 represent the second number. So when we solve this, we need to set up our model. So we know that x, our first number, plus x plus 3, which is our second number, is equal to 23. So we know this because x is our first number. X is our first number. We'll use red. And then, so this is number 1. Let x represent the first number. And we also know that x plus 3 is our second number because we defined it so up here. So you don't have to put that in brackets. You can leave this equation out of brackets and you're going to get x plus 3 equals 23. They're the same equation. So if you remember when we distribute polynomials when we're adding, we just simply remove the brackets. So here we've got our let statement, we've modeled our equation. Now we're going to solve the equation. So when we solve this equation, I'm going to go back to my pens. We're going to add. So we're going to collect the like terms. X plus x is 2x. And we are going to take that 3, that plus 3, and we're going to send it over to the other side of the equal sign. When you do this, you need to change your integer sign. So it's addition there, we're going to make it subtraction. So solving, collecting like terms on the left side, 23 minus 3 is 20. Isolating the variable here, what we've been working on, These cancel out because you always want it just as x. I'm going to write it over here. X equals 10. So now we have to write our therefore statement. So therefore, we can actually do our dots for therefore. Therefore, they're not very visible. There's 1, there's 2, there's 3. So our therefore statement, one number is 10. So we said x is equal to 10, but we have two numbers. So let x represent one number. One number is 10. The other number is x plus 3. And the second, I'll fix this in a second, number is, so x plus 3 is 13. So those are our two numbers. One number is 10, one number is 13. So set up your let statement, model your equation, either way was fine, solve your equation, and then finish up with your therefore statement. One number is 10 and one number is 13. Let's move to example 2. So James is 4 times older than Adam. Adam is 3 years older than Jen. The sum of their 3 ages is 111. How old are they? So here we need to define our variables. So something is happening to Adam's age because James's age is 4 times Adam's age. And then something is happening with Adam's age. It's 3 years older than Jen. Jen's age is the base age. So Jen gets the variable x. So if we are going to let x represent, we're going to let x represent Jen's age because she's kind of the base. Nothing's happening to her age. But then we've got to deal with Adam and James's age. So Adam's age is 3 years older than Jen. So he is Jen's age plus 3. Okay, so this x is just Jen's age. This whole x plus 3 is Adam's age. Then we get to James's age. So James is 4 times older than Adam. Here you can see that Adam's age is represented by x plus 3. So if James is 4 times older than Adam's age, James's age is 4 times older than Adam's age. Okay, so those are our let statements. This is a little bit tricky, I get this, but you've got to find who nothing's happening to. So Jen is the base. Her age is just her age, so that's why she gets x. Adam is 3 years older than Jen, so he's 3 years older than Jen, just that x. And James is 4 times older than Adam. So we have to take all of Adam's age as it's represented and multiply it by 4. The sum of their ages is 111. So then we're going to get to our equation. So our equation here, we have Jen's age plus Adam's age, which is x plus 3. Then we have to add it to James's age, which is 4 times x plus 3. And their age is equal to 111. So at this point is where we are going to start solving. So first we need to distribute this into the bracket. We don't want these brackets here anymore, and the way we do that is by multiplication. So I'm going to collect these two like terms here and call it 2x. And then we have our plus 3. And then 4 times x is 4x. And then we have 4 times 3, which is 12. That's plus 12. And we know that that is equal to 111, not just 11. So let's fix that there. Okay, So here we're going to collect like terms on the left side of the equation. So we're going to add our 2x. Oops. We're going to add our 2x and our 4x. So 2x and 4x is 6x. Then we're going to add our 3 and 12, and that gives us 15. And that is all equal to 111. So at this point, guys, you should be able to recognize how to solve this. So we're going to take this positive 15 and send it over. So we're left with 6x here equals 111. When we send things over the equal sign, remember to change the integer. So that is going to be 111 minus 15. This is going to equal 96. Divide both sides by 6 to isolate x because we want x alone. And we are going to be left with x equals 16. So that means what? What does x mean? Well, x is Jen's age. So that means Jen is 16 years old. So therefore, Jen is 16. And then Adam is x plus 3. So 16 plus 3 is 19. So Adam is 19. And then we've got to figure out James's age. So James's age is 4 times x plus 3. So if we sub in 16 for x, we get 16 plus 3. So 4 times 19 is going to give us 76. So that's how old James is. So James is 76. So this is how you solve this question. So when you get your x, make sure that you're subbing it back in to solve for your variables. It literally becomes the variable in this expression. So this is how you get all of their ages. Example 3. So Amy has 15 more dimes than nickels. If she has $2.25 or 55 cents, how many nickels does she have? So think about this for a bit. Amy has 15 more dimes than nickels. So she has more dimes than nickels, 15 more dimes than nickels. She has a total amount of money of $2.55. How many nickels does she have? So we want to know how many nickels she has. So the value of nickels, let n represent amount of nickels. Let n plus 15 represent the amount, of dimes. So we know that she's got nickels and dimes. N is the number of nickels. N plus 15 is the number of dimes. But we also need to know the value of each. So we know that the value of nickels in terms of dollars, because we're working in dollars, is 0.05. So we know that this is the amount of nickels in dollars. And we also know that the amount of dimes in dollars is 0.10. So we need to multiply these numbers here, our variables, by the amount in dollars, because we are given a dollar amount here. So this question is really tricky. So if we were to model this, we would have the amount of nickels with the value. So the number of nickels and its value plus the number of dimes and its value. So if we're going to multiply, think about that for a second. N represents the number of nickels. The value of this number of nickels is 5 cents times that value, times that number of nickels. So that is our first expression. Our second expression is this. So if we're not looking at the 0.05n right now, we're going to just look at this part here. So we know that n plus 15 is the number of dimes, but the value of dimes is how much the dimes are worth, so 10 cents multiplied by the number of dimes. And this is going to give us a total of $2.55. So hopefully you followed along with that. I know that this is a tricky question because we're dealing with the quantity and the value of the money all at once. So when we start to solve this, this is already in its simplest form. And then you are going to distribute this by multiplication. So, So 0.1 times n is 0.10n plus 0.1 times 15 is 1.5. And that is all equal to 255. So here, collecting like terms, we're going to add these two together. So we're going to get 0.15n. And then in the same step, I'm going to send this to the other side of the equation. So this is going to be equal to 255 minus 1.5. So my next step, I'm going to have 0.15n is equal to 1.05. So at this point is where we are going to isolate our variable. So here we're going to divide by 0.15. What we do to one side, we do to the other, 0.15. And we are going to be left with n is equal to 7. So what does this tell us? N is equal to 7. This means that, therefore, there are 7 nickels. If there are 7 nickels, how many dimes are there? Well, we sub 7 back into our equation up here. So if we take 7 and we add it to 15, what does that give us? Gives us 22. See, there's my skills. And 22 dimes. So this question is hard because it asks about the quantity of money and the value of the money. So not only did we have to assign the variable, but we had to assign its value to it as well. So this is a really tricky question. So rewatch the video if you are unsure. Question 4 says there were 16,000 people at a football game. Some paid $5 for their ticket and others paid $2. There were 4,000 more $2 tickets than $5 tickets. The total revenue was $50,000. How many of each kind of tickets were sold? So we are going to set up our let statements. So we're going to start with let X represent the number of $5 tickets sold. Okay, so we're going to start there. I know I didn't do a lot of explaining why, but I'm going to go back and explain it now. So we know that there are a total of 1,600 people at the football game. We know that some people paid $5 and others paid $2. There were 4,000 more $2 tickets than $5 tickets. So the comparison is with the $5 tickets. Nothing is happening to that $5 ticket. So that's why we're calling X the $5 ticket. So then if X represents the $5 ticket, we're going to have let X plus 4,000 represent the number of $2 tickets sold. Because right here it says there were 4,000 more $2 tickets sold. So this is how we're going to set up our let statements. From here, we are going to come up with our equation. So we know the total number is 1,600. So if we add the number of $5 tickets sold plus the number of $2 tickets sold, that should equal 16,000. To solve, start collecting like terms. So 2x's together is 2x. And then again, like we did in the last example, I am going to send this over to the other side and show that I am subtracting 4,000. So here, when we simplify, 2x is equal to 12,000. And then we are going to divide out the 2x, or the 2, so that our x is alone. And we are going to get a value of x being equal to 6,000. So what does this mean in terms of our question? Therefore, 6,000. So what did X represent? Well, we said X represented the number of $5 tickets sold. So this X means that there were 6,000 $5 tickets sold. And if we know that X is 6,000 and that represents the $5 tickets, the $2 tickets are X plus 4,000. So we're going to add 6,000 to 4,000 and get 10,000. So we know that there are 10,000 $2 tickets sold. So we know that the total revenue here, it says, is $50,000. So you can multiply 6,000 times 5 and add it to 10,000 times 2, and you should get 50,000. I'll leave that for you guys to check. So if you want to pause the video, take a pause right now and check to make sure that this is confirmed here. And lastly, I know this is a long lesson. It's long for me too. Marissa and Sandy ran as far as they could in 30 minutes. Sandy ran 2.5 kilometers further than Marissa. They ran a total distance of 9.5 kilometers. How far did each girl run? So we're going to start with our let statements. And I'm going to use D to represent distance. So who's got nothing compared to them? Whose distance is the one that's alone? So we know that Sandy ran 2.5 kilometers farther than Marissa. So it has to be Marissa's distance plus 2.5. So distance is going to represent Marissa's distance. Then we're going to let D plus 2.5 represent, let's put in represent here, represent Sandy's distance. Okay, I'm getting tired. I'm forgetting my apostrophes. And then since we've defined the variables, we know that their total distance is 9.5 kilometers. So we're going to set up our equation of Marissa's distance plus Sandy's distance. And we know that that is going to equal 9.5. So here you're going to solve the equation. So collecting the like terms, 2D is equal to 9.5 minus 2.5. So without showing it, I took this 2.5 and I sent it over to this side of the equation and changed the integer sign to subtraction. So we're going to get 2D is equal to 7. And then isolate the variable because you can't have the 2 attached to it. So we're going to divide by 2, both sides. So D is equal to 3.5. So I changed it to a decimal because we're dealing with distances. We're not using rates or anything right now. So because it's given as decimals in the question, I'm going to change it to decimals at the answer. And we know that this 3D represents kilometers. So therefore, Marissa's distance, because she is represented by D, distance ran is 3.5 kilometers, and Sandy ran 3.5 plus 2.5, so she ran 6 kilometers. And that is it. And let this sink in, re-look at it, check your notes, just let this kind of mull for a bit. This is a lot and it's really theoretical, and I know it's really hard to do from home. So don't rush in to doing the questions. Just take a minute. This was a long lesson. And if you have questions, send them to me on Edsby.